Today I'm going to show you how to build this amazing portal in Blender. This project is based on a video by Cartesian Carmel. You should go check that out on his channel. It is much longer and goes in much greater depth on the whole portal simulation. In this video, I'm just trying to simplify that effect and make it a bit quicker to learn. To get started, first thing we'll need to do is create a new geometry nodes network on a cube. I'll name it Portal. The first thing to set up is a base mesh, in this case a curve for the particles to spawn from. And we're going to do that using an arc node. We can delete the input, we won't be needing that. And here's what the arc looks like by default. We'll turn up the resolution to something like 100. Also, you can make the radius bigger. And we can control these values here to adjust how much of the circle it is. And to make the portal beginning effect, we will keyframe this value so that it closes over time. Open up a timeline, and at frame 1, we want this angle to be just 20. Hit I to make a keyframe for that. And on frame 70, we'll have it be a full 360 degrees. Press I again to add another keyframe. Now if we hit play, it slowly closes, which is perfect. Let's increase the frame rate, bump it up to 30. Okay, that's great. Now we just need it to spin, and to do that, we can animate this start angle here, and we can do that with a driver. Just type $, then frame for the frame number, divided by -3. And I only know that works because I have tried it. Now if we play the animation, it looks like that. Much cooler. Could probably also animate the scale over time, but I'll leave that up to you if you want to do that. Next step is to rotate it. It's laying down right now, and that's no fun. So let's add a transform node and set the rotation on the Y to 90 degrees. There we go. Okay, now we need to spawn some points on this curve. To do that, we're going to need a sample curve node to get positions on the curve. And for this factor, we're going to use a random value from 1 to 0 with the frame number as the seed. And to get the actual points, we'll use a points node and plug this position into there and connect it to the output. We have 1 point, changes randomly every frame. Let's change that number to maybe 1,000 points, which is starting to look far more interesting. They still each point only lasts for a single frame. We'll change that soon. But first we're going to add some more randomness to where they're spawned. It's a good idea to put these in frames. Command J or Control J to do that. To add more randomness, we'll just use a vector math node and add in a random value to each position. We'll need a random node. That is far too much. Let's make the max 0.1 and the minimum -0.1. Already looking better. Also, let's use a random seed or a different seed each frame. We'll just use a frame node again. Though to mix things up, let's add some obscure number to that so that it's different from the other one. Put those all in a frame. Great, we've already got our points. We have the positions generated on a curve, then we randomize those positions and make points. And if you're wondering how the sample curve node works, it simply takes in a curve and a factor. The factor tells where on the curve the output position should be taken from. So based on this factor, it gives an output position that is somewhere along the curve. And since we made the factor totally random every frame, we just get a random point on the curve somewhere. And then we add random values to that and plug it into a points node to get 1,000 randomly generated points along that curve. The next step is to turn these particles into a particle simulation. For that, we will need some simulation nodes. And these nodes are only in the Blender 3.5 simulation branch. I've left a link to that in the description so you can get it. It's getting harder to find, but it's not impossible. First add a simulation output node, then add a simulation input. And we don't need that input there. So everything between these two nodes will run each frame. The geometry from here will do things to that. When it gets to the output node, it gets sent right back to the input node. Imagine an invisible connection going from here to here, updated every frame. So all of our points, we need to join into here every frame with a join node. Join geometry, plug that in. Now if we hit play, they all just add up, which is very inefficient. They will need to be deleted after a while. So we'll handle the deleting later. Actually, we'll do the deleting first. To delete them, we need to set an age attribute so we can check how old they are. And that is extremely simple to do. All we have to do is add a store named attribute node. And this attribute will be a float. We'll name the attribute age. And the value will be a named attribute named age. And we'll use a math node to add 1 to that. So every frame will read the age attribute on each point, add 1 to it, and store it back in the age attribute. So every frame, each particle's age attribute will go up by 1. So it gives its exact age in frames. Put these in a frame. Now we can delete the particles based on that age. Add a delete geometry node. We will duplicate this named attribute. You can press Option P to remove a node from a frame that it's stuck in. It's extremely handy. Now from this attribute, we'll add a greater than node. If the age is greater than 20, we will delete the particle. Or the point, I suppose. Now if you hit play, you can see they do get deleted after 20 frames. They're changing, which is perfect. Put these in their own group. Now we need to give the particles motion. To do that, we're going to set a velocity attribute, which we'll use to set the position of each particle every frame. Add another store named attribute, name it velocity. I'll just call it vel because that is easier to type. Add a set position, put that there, and the position will be set to named attribute vel, which actually should be a vector attribute. Vector, plug that into the offset. Put these in a frame. I do highly recommend that you watch the original tutorial for this. It goes into a lot more detail, teaches you a lot more about this. This one is just sort of a sped up version. Okay, now we need to set a value for this velocity. And here is where some math comes in. First thing we'll do is take a position node and plug it into here, which will do nothing setting its position. Never mind, that will do something. We're offsetting it by its position, not setting it directly, since it's going to the offset here. That makes a crazy mess. That's interesting. But if we take the cross product with a vector math node, the cross product gives a vector directly perpendicular to the two input vectors. So one input vector is the position, and the other vector we can pick. We could use it in the x-axis or the y-axis. That is awesome. Or the z-axis, which makes a lot of interesting stuff, really. There's probably a lot of cool things that should be done with this. But if we put a 1 in the x-axis, they will fly directly outward on the x-plane, and we can duplicate this and switch it to normalize. Normalize makes sure that the magnitude of the vector is just 1. A nice, healthy 1. Nothing extreme. Now we have a big mixer effect. We need to scale that down. Use a scale node. Okay, and we want to add this to the velocity, the existing velocity every frame, so that the velocity, I'll leave that scale at 1 for now. So the velocity increases every frame. So we need to get the existing velocity. Just duplicate this node. And get an add node. Duplicate that, switch it to add, plug that in there. Add this to it, and plug it in. It is far too extreme, still. Let me make some room. Okay, we'll need a scale node right here. Change that to scale. And scale it down quite a little. Actually, leave that at 0.9. Let's adjust the scale down here. Okay, that is looking good. It is far too regular, so we will have to add in noise later. First, let's make gravity. Yeah, first we'll make gravity, we'll do the noise next. The gravity is extremely simple. All you need to do is add a negative z vector every frame. So negative 0.01. Now we have gentle gravity. We can make that strong or weak or whatever. But just a gentle gravity effect is best. If it's too strong, it will look unnatural. Alright, we got the gravity, let's add the noise. So let's get a new add node right here, so that it will be adding it to the velocity every frame. And from here, let's get a noise texture. We'll use the color, not the factor. And we need to subtract from that. Subtract 0.5, so that it goes in all directions, positive and negative, not just one direction. And let's get a scale node so we can control how strong that is. I'm actually gonna give myself some more frames here, maybe 1,000, so that it stops starting over. For the vector of this, we'll just use position, and we'll add to that position in every frame. Let's see, 0. Let's add to the Z to animate the noise moving. To make a driver, just type pound here, and then frame. We'll give you the frame number, and we'll divide that by 10 to make it weaker. You can barely see the noise moving now. Let's change the scale so that it's more visible. That is awesome. It's probably too big. Let's try 2. Okay, that looks very nice. And another useful trick that Cartesian Caramel taught in his video was that you can control this scale with the age. If I just duplicate this age value and plug it into the scale, that's crazy. We're going to need a map range to control it. Map range is like a color ramp, but for numbers and a little bit simpler. So the age goes from a minimum of 0, a maximum of 20, to, and we will map it to a minimum of 0 and a maximum of, what do we have, 0.3, 0.4. So now the noise gets stronger the older the particle is, when we can compare it with and without. Hit M to mute nodes. Oh, I'll just do that. That was without. This is with. Now the particles right here in the middle keep the circle shape. Further out, they're more noisy. And let's put all those noise nodes in a box. Control J. And let's also scale the velocity using the age. Grab these 2 nodes here. Duplicate. Move that out of the way. Alright, that is way too strong. Let's make the minimum 0.05. And the maximum, same thing. Already looks better with weaker velocity. And let's make the maximum lower than the minimum. Maybe half of it. The older a particle is, the slower it will go. It's already looking very portally. Let's put these ones in a frame. And let's put all of these into a frame. It's a very clean and simple node tree. We start with our curve right here. We add some randomness to the particle positions. Turn that into actual points. Then we make an age value, delete them if they get too old. Set up a velocity value, offset them with that. In every frame, that velocity value gets added to itself, plus some additional velocity here with extra noise added in, and that works out really well. The next step is to turn this into an actual mesh. These are just points, which is totally boring. We can just add a simple stick, a little curve on for each point, and it will fake the idea of motion blur. Another great thing that Cartesian Caramel demonstrated in his video is that you can fake motion blur by instancing cylinders or curves on each particle, and they'll look like they're blurred from moving fast, even though they're not. And doing that is really simple. Let's just add instance on points node, and we'll be instancing a cylinder. We don't need 32 let's just have 3, and let's make the radius smaller. We'll do that next. Yeah, that's too big. Let's make the radius 0.01. I think that is still too big, 0.009. We might have to adjust that. We need to align the cylinder in the direction of the velocity, which is simple since we already have a velocity value. Take the velocity in a named attribute node, add in align Euler to vector as the vector, and z, we want to align it to the z, and put that into the rotation. Ah, awesome. And we will get the magnitude of the velocity vector, how large it is, with a vector length node. Tells you how long or what the magnitude is of that vector. And we'll use that. The multiply to control it. We will use that for the scale. So that the more velocity it has, the bigger the cylinder. That's too big, too small. Right there, 1.5. And it's slowing down, but if you realize the instances with a realize instance node so they become real mesh, it actually speeds up, which does not make sense, but works. Because instances are supposed to be faster than an actual mesh, but in this case, the actual mesh is faster. Okay, and we now have the whole portal node network. It's a lot simpler than it would seem at first glance. The key things to remember are you can change the velocity scale, the dampening, just by adjusting this. Weak, strong. You can adjust gravity here. You can mess up this to change the velocity. That could potentially be interesting. You can also use this to add wind. You could add in any other vectors here. Like if I do that, now there's a strong wind from the y direction. You can control the noise down here. There's probably a lot of interesting things that could happen. We could adjust the detail, more detailed, negative detail, zero detail. Actually, zero detail looks a lot better. I'm going to keep that. Really, the more randomness and the more erratic the portal is, the more realistic it looks. Alright, let's set up a material. Add a set material node. Put it right here to set a material on the cylinder. We'll just use the default one. And let's switch this to shading nodes. Shader editor. Let's switch this to rendered. And make the world totally black. And turn on bloom. Okay, we'll delete the principled node and add an emission shader to make it glow. Already looks very cool. And a neat trick that Cartesian Caramel demonstrated in his tutorial is that you can use an add shader and add the emission to a transparent, and then use the strength of the emission to control the transparency. First, we need to enable transparency in the material settings. Right here, change blend mode to alpha blend. It's way too bright. So we're going to control the brightness of each particle, each cylinder, using our age attribute. The older it is, the less visible it will be. And you can access your geometry nodes attributes in shader nodes using an attribute node. And you just type in your attribute in here, age, and we'll plug this factor into the strength. We need a map range node to control it. Minimum 0, maximum 20, and the max, we want it to be completely dark for the higher ages, and you can adjust this. I think 5 looks great. Now let's pick an orange color, or red, or pink, or purple, or green. Will pretty much look cool no matter what, but I'm going to go with orange. And I'm not sure why my Eevee is not playing all the way. Maybe I should try it over here. It seems to be playing slowly. I had better performance last time I did this. Let's take a look at the settings. No denoising. Ah yes, there's a denoising. Turn that off. Also turn the sampling down if you want to speed up a little bit. Actually, I might tweak the nodes a little bit. Let's see. We can change it from linear to smoother step. I think it makes it look better. And back to geometry nodes. I forgot we can change the fill type here to none. The cylinders do not need ends. That's just a waste of geometry. Also, they are rather long, I think. I could adjust the scale here, or I could adjust this depth, which is the height of each cylinder. Put it to 1. Ah, yes. I think that looks better. We now have an official portal, and it is awesome. So that's it. That's the whole project. Not as complicated as it sounds at first. Turns out simulation isn't actually that much. It's just a few nodes. I'll put all these in a group to keep it clean. If you like this video, I highly recommend that you check out my newsletter, The Blend. Every week I'm sending out an article or mini lesson on something Blender related, and you'll probably learn from it. It's always interesting, at least. Sometimes it has a cool render in it. Oh, I also figured out a way to turn this simulation off, because the portal starts, but it never stops. If you want your portal to stop, add a switch node here, which will switch between this geometry here and this geometry here. And if we leave this one empty, when you check the box, it will switch to node geometry, which makes the portal disappear. So you could animate that to turn the portal off if you needed to. Alright, that's it for the video. The portal is complete. Thanks for watching. Have lots of fun doing stuff with your portal.